Okay, today's going to be a really quick little lesson on what's called line notations. This is really a shorter way of writing electrochemical cells because it gets really kind of tiring to draw these pictures out all the time. So if we want to represent this picture without necessarily having to draw each step out, we can use what are called line notations. Now, little bit of advice here. The AP test doesn't do much with line notations, so I wouldn't put too much time and energy into this. So if they get overly complicated in the homework, skip them. If you're going to see any of these kinds of things, they're going to be relatively simple. So if you have any questions on it, let me know. But here's the rules for dealing with line notation. First of all, your anode is always written on the left, so make sure that you always write the anode. You're always going to start with anode, and I always remember this because anode starts the alphabet off because of the A, so that's always going to come first. Your cathode is always going to finish it, and it's going to be on the right-hand side. There's double vertical lines. Vertical lines separate the anode and the cathode. That is your salt bridge. Remember, that's what separates out the anode and the cathode is the salt bridge. So your double lines, these double vertical lines that you're going to see, is what's referred to as the salt bridge. Okay, single lines are going to be phase boundaries. So if you have a solid and a liquid or a solid and aqueous, you're going to separate it with a single vertical line. And we're going to put in concentrations and pressures if you can. Sometimes they don't give you that information in the problem, so if they don't give it to you, you don't have to include it. But if they do, you would just put it in parentheses, and I'll show you in the second. Your anode electrode is always in the farthest left. So this is always what starts it, is your electrodes, and what always ends it is the cathode electrode. So let's take a look at an example. This again, remember, this is really not a battery. This is a voltmeter. The electrons aren't really going in this direction. They're going in. They're coming from the zinc to the copper. So this would be your cathode. Okay, sorry about the picture, and this would be your anode. Okay, that's what the picture was for an electrolysis that we'll look at later. But for now, we have a voltmeter here, and we're going to measure a voltage of 1.1 volts. Anyway, what we want to do is we want to take this picture and convert it into a line notation. So we always start with the anode first. So we have our anode here separated by the salt bridge, and then our cathode. Okay, so our electrode here on the anode side is a metal, and it's zinc. So we're going to put zinc solid in here. In the solution, what we have is zinc ion. So we put a single line for phase boundaries. So if I have a solid aqueous and solid and an aqueous, we use a single line to separate those out. Okay. On the other side, I have a positive charge. Positive copper ions in solution. I put those here, and then I finish with the cathode electrode. So we always end on the electrode and start on an electrode. All right, and that's pretty much it. Always anode and cathode. Now my picture matches the direction. Don't always think that's going to be the case. They may flip that around so it's not in the same direction. So be careful with that. Here's a little list of things to be able to do if you're going to try to describe galvanic cells. Things that you always want to put in here. Cell potential. Always make it positive. So the direction of electron flow has to be, and that's why I reversed all of this, because I knew that the electrons went from zinc to copper, so I switched everything around to make it proper. Okay, so make sure you make it so that it produces a positive voltage. Balance the cell reaction, so make sure if you give your reaction, you balance it. Put the directions in the correct version, like I said before, making it positive. Make sure you designate the anode and the cathode. Remember, electrons always go from anode and move to your cathode. The nature of each electrode, ions present, that would be the line notation. Include platinum if necessary. Now I'll show you where platinum is going to come in just a second. What does this say? Be able to describe a galvanic cell. Okay, so just make sure you can remember it's the two half cells, half reactions. All right, so I'm going to write, here's another reaction here. This is in normally what you would see. You don't always necessarily see the pictures. What I'm going to do is I'm going to rewrite this in sign notation. First thing I have to do is figure out which is the anode and which is the cathode, right? I got to figure out what those directions are. So 0 on the iron and a 0 on the oxygen, or sorry, the hydrogen. And my hydrogen here is a positive 1 charge, and my iron has a 2+ charge. All right, so what's going on? This positive hydrogen ion is going down to a 0. So that would be my reduction. Iron is going to a positive 2, so that would be my oxidation. So this is going to be my cathode, and this is going to be my anode. So what metal would I use for the anode? I'm going to use iron solid. So I have iron solid is my cathode. And I'm going to put a line barrier because what's happening is that iron is going into an ion. So I'm going to have iron 2+. And I'll put aqueous here. Now if I knew what the concentration was, let's say it were 1 molar, I would put that in parentheses. I wouldn't worry too much about that. That's going a little above and beyond. Double line, because that's my anode. Okay. Now for my cathode, I start with hydrogen ions. Don't worry about the stoichiometry. We're not worried about that. We're just representing what's in there. And that hydrogen ion goes into hydrogen gas. Now here's the problem. Because I have a gas and an aqueous, I don't have a solid electrode, but I have to have an electrode in here. If you don't have a solid electrode, that's when you end on platinum solid. Always use platinum. It's a very good inert metal to use. So notice that I start on a solid and I end on a solid. And this would be my line notation. Now if I were to draw that out picture-wise, it would look like my anode on this side. I would have a solution with iron ions in it. Okay, and I would put inside of that a solid piece of iron, so this would be solid iron. And on the other side, what I would have is I would have my cathode on this side with the hydrogen. I would have hydrogen ions in here. I would have to put that little device with the little tube on here so that the hydrogen gas can be pumped in. Okay, go back to the picture that I showed you before. I have a wire here coming down, connecting to this here. And I would have on this a little plate, and I would put platinum on there. And don't forget your salt bridge. Salt bridge. If they ever ask you what to put in the salt bridge, put something like sodium nitrate, potassium nitrate, okay, some sort of nitrate that's with it. Remember, these are all those spectator ions are really what you want to put in here. And that would be it. So that would be the sketch of the line notation. So there you go, guys. It's your quick little video lesson on line notation. See you later.